All right. Well, on that note, let's go ahead and get started, guys. Are you good back there? All right, I'm recording up here. So, welcome to the 8th General Body Meeting for ACM at UC. We're into the spring semester now, so I hope everybody's doing good. If you have not already checked in at acm@uc.org/c, please do that. Make sure to note you're there. It helps us to hopefully not overestimate or underestimate on food. It helps us know who's voting eligible when we get to the end of this semester. And you'll need to be a general body member if you want to run, which means signing into at least 2 meetings. So, I've got a couple of reminders like I always do. You're being recorded back there and up here so that we can put these talks up on YouTube. Sometimes there's a little bit of a delay there, but it does happen eventually. Sign in if you haven't already. And then if you'd like to be on our member directory on our website, all you have to do is go to our GitHub repo there. If you search up the ACM at UC website on Google, it'll come up, and there are pretty explicit instructions there for adding yourself. So feel free to do that. We're watching for pull requests there to add people. We are again doing office hours, so if you are interested in coming and talking to us about a class you ran, about a homework, about an upcoming test, you can do that. We know that there will always be somebody in the 802A ACM office during these times, Mondays from 6 to 7 and Wednesdays from 1 to 2. So feel free to come hang out with us. You don't have to be there to talk about homework you got coming up. Maybe you're just killing time on campus. Come hang out with us. We'll get to know you. You'll get to know us. It'll be good. Slack, if you're not on Slack, you should join Slack. It is our main way to take the communication and the conversation that we have at meetings and take it offline into online into the World Wide Web. And so there's always conversations going on, Hacker News articles being posted, and so on and so forth. So it's a good way to stay up to date on what's happening and interesting and funny things and things like that. Code of conduct applies there, though, so you can sign up at acmcincy.slack.com/signup if you aren't already there. Revolution UC is coming up. We are actually a month away Saturday, so get excited about that. Who in here is not signed up for Revolution UC? Okay, if you're not signed up for Revolution UC, you should sign up for Revolution UC. It's our student hackathon. If you've never been to it before or you're a freshman, it's a 24-hour event. A bunch of people come together, almost 300, and we go to the 8th floor of Rhodes, and people work together on projects. And it's really open-ended what they can build. If they want to build a website that solves a problem, a game that you've always wanted to play, or something entirely different, they are allowed to do that. You can build a hardware hack, a software hack. It's really open-ended, and at the end you get to show off what you worked on, and some of the coolest hacks will win prizes. So it's entirely free. All your meals are paid for during the event. You get snacks, you get Red Bull, all that good stuff. You don't have to stay the whole 24 hours if you want to go home and sleep in your bed overnight. I know that's what I do. I can't stay up 24 hours anymore. Come out. It's a great time, and at the very least you'll get to try it, and maybe you'll fall in love with it. So no experience necessary if you're a freshman and you are just now in your CS1 course. The experience you've got from Models 1, Models 2 in that CS1 course is more than enough to get something done. And we'll be doing a Hackathons 101 meeting, the meeting directly before Revolution UC, so that would be your chance to find a team if you don't have one, to come up with an idea and to talk about what actually goes on at a hackathon in a little bit more depth. So register as soon as possible because we will hit capacity at revolutionuc.com. I mentioned this at the last meeting. This is probably the last time I'm going to mention it until we get a little bit closer to elections. But spring semester means we are constitutionally obligated to hold elections at the last meeting. And so that means we're not a dictatorship, we're a democracy. And we elect 5 positions: our chair, myself, our vice chair, which is Dom, our secretary, which is Noah, who's in San Diego right now, our treasurer over there, Zach, and our webmaster, Isaiah. Wait, where is Isaiah? No experience is necessary to run. All you really need is a passion for it. I certainly did not have any experience when I got started with ACM. But to run or to vote, you need to have signed in to 2 ACM meetings. So make sure you do that. If you've maybe only signed into one, make sure you get it to another one so you can sign in. And if you don't know how many you've signed into, you can ask Noah on Slack. He would be more than happy to help you out. So if you have questions about the positions, about the involvement, about what really happens on the exec board, feel free to reach out to any of those people that I just mentioned or one of our committee chairs, Christian, Maddie, or Andrew back there. So elections will be the last meeting of the spring semester, which right now is projected to look like April 12th. So our next meeting is going to be Thursday, February 15th at 6 p.m. in Swift 819, and it's going to be a really cool meeting because we're going to be doing an MLH localhost. So MLH is Major League Hacking. They're the group that helps us put on the hackathon, and they have built up a couple of workshops for students to give to student groups. And so we're actually going to do their one on Docker. If you aren't familiar with Docker, it is a container system. Containers are this new trend that's really taken over a little bit of the web world. And so we're going to go over what it means to run an application in a container and how to actually use Docker. And so it's cool, it's going to be super polished, and you're going to walk away with definitely links to free Docker resources. So today's meeting is to talk a little bit about technical interview tips, what it means to be in a technical interview, how to actually solve the problems you're given in a technical interview, and kind of the behavior that's expected of you. Before we start, how about a show of hands if you have been in a technical interview before? So if you see these people with their hands up and you have a question, because at the end we're going to get to a couple of questions you can do in small groups. Those are going to be good people to ask because they've been in it, they've seen it. It's not a big deal if you haven't, especially if you're younger, even if you're older. A lot of co-op companies won't actually do technical interviews until you get to being an upperclassman, or maybe not at all. So don't worry about it if you haven't. If you have, I'd love it if you shared your knowledge with other people once we kind of break out into groups. But I have a couple of things to talk about things to say about technical interviews before we get started. So technical interviews are kind of a cornerstone of the computer science, software engineering job search. You could start getting technical interview questions as soon as your first co-op search. It's not very likely, but you could depending on where you're applying. And if you master these techniques now, they're going to be important all the way through the entirety of your career because they're never going to stop happening. If anything, they'll just get harder as you move up in seniority and expertise. So what is a technical interview? A technical interview for computer science or a software engineering position looks like being asked to maybe code on a whiteboard or asked to code in an online environment while you're on the phone or in person with your interviewer. They're testing your skills of basic data structures maybe, or of writing algorithms, or maybe just how you approach a problem. In some ways, being asked to solve a brain teaser is the same thing as a technical interview because while it might not test your knowledge of data structures or algorithms, you're still going to be asked to explain your thinking, and that's what they really care about is how good a thinker are you? How do you approach a problem that you don't know the answer to? You're probably not going to see a problem in an interview that you know the answer to like that. It's going to be something you have to think over, you have to mull over, and that's what they want. They want to see, is this person not going to give up at the first sign of adversity? Are they going to try and solve this problem? I know they're under pressure because they're in an interview, but that's okay. Let's see how they solve it. So, before the interview, there's a couple of things you want to do. You want to review your data structures, and these are, you want to take these with a little bit of leniency depending on where you are in your semester, in your career. If you are a freshman or a sophomore and you're out there looking for your first co-op, you've probably not even had data structures yet. And so do you need to review your data structures? Only really if you're applying for, Google or Facebook or something like that. But if you are a senior engineer at a major company, do you need to practice your data structures and your system architecture? Yes. So it really depends on where you are. But as a general rule, it's a good idea to know your data structures, to do some practice problems. You'll never do a good job if you don't practice what it's actually like. It's one thing to think it over in your head. It's one thing to write up a solution to a problem and then compile it. It's another thing to do it live with somebody else on a whiteboard or typing out. Read up on the technologies the company uses. If you're interviewing at Snapchat, know a little bit about mobile development, that type of thing. You don't necessarily have to have experience, but you should know and be familiar with what they're doing. You should look up previous interview experiences with the company. Lots of people go to interviews, don't get the job, and then they're disgruntled, so they go online and write all about the interview. So you can go online and find those and see probably not the questions you're going to be asked, but the type of questions. And then be familiar with your resume because your resume is going to be looked over during the interview. So if it's on your resume, it is legal for the interviewer to ask you about. So don't put MATLAB on your resume if you've never coded a line in MATLAB, or if all you've done in MATLAB is say hello world. It's not a bad idea to differentiate between your skill levels with languages or frameworks or things like that, but the bottom line is that if something is on your resume, you should be prepared to talk about it because it's legal for them to bring up. Legal. It's reasonably expected that they'll bring it up. So if you have a couple of projects on your resume, that's a great idea. It's a good way to show that you take initiative outside of class. Computer science and software development is a little bit different in that aspect from maybe other engineering majors, and that it's easy to set yourself apart by doing those projects and being involved in open source, and just putting something on GitHub and showing that, hey, outside of class, I'm there trying to learn new things. I care about, I'm excited, I'm motivated. And one great way to get a project onto your GitHub or onto your resume is to do a project at a hackathon. Maybe you'll even win and you can put that on your resume as well. And while you're thinking about doing a project at a hackathon, I hear there's one right here you see on March 3rd and 4th. I believe you can sign up for that at revolutionuc.com. So, what to expect? It's hard to say because it varies a lot from company to company. In general, you'll probably know that it's going to be a technical interview, so you know that you're going to need to go in there with your analytical and your problem-solving mind hat already on. You probably won't know the answer right away. It's not a very good question if you do, and you might not know the answer at all. Plenty of people go through interviews and don't ever get the answer. That doesn't necessarily mean it's an automatic no. Like I said, the real purpose of these is to see how you think, to see how you approach problems. Your interviewer's a person too. They're a lifeline. They're not some evil monolith that's standing there just wanting to see if you get yes or no. They want to see you succeed. They're going to give you hints as you need them. They're going to point things out. It's a discussion in a lot of ways. And then you're nervous. That's okay. Every person that interviews with that interviewer is nervous. So they expect it, and they know you're nervous, and so you kind of just have to do your best to manage your nerves and stay on top of things. But like I said, your interviewer is a person as well. So in a technical interview, you're going to be given a problem, and that problem could be a brain teaser. Why are manhole covers round instead of square? Or it could be an algorithm question, like finding the middle element of a linked list. And so those are two questions I actually have prepared here. So the important thing is to look at the problem and don't immediately freak out if it's something that you don't instantly know the answer to, like I've said. It's a test of the type of problem solving you're going to do on the job. It could involve using algorithms. It could just be a brain teaser, like I said. And it might just be a simple definition problem. Tell me what inheritance means or something like that. So in the case that it is one of those coding problems, or maybe even a brain teaser where there's a little bit of ambiguity. Ambiguity is oftentimes a core concept of the technical interview because, like I said, it's a test of the skills you'll be using on the job, your problem solving, how analytical you are. And so ambiguity is something that is all around you when you're working. You don't ever have 100% defined requirements or know exactly how your product is going to be used. And so they want to see that when you see ambiguity, you know how to handle it and how to work with it. And so when, for example, you're asked to deal with a string and you need to work with the characters, maybe they want to know how many of each character in the string. And so when you're thinking about how you want to implement that, it's important to ask, okay, well, what are the allowable characters in the string? Because it could be UTF-8 and there could be Chinese characters and emojis, or it could be just ASCII capital A through lowercase c, something like that. That's the kind of ambiguity that they want to see you notice and pick up on. So let's say we had that problem there that I just mentioned where they've given us a string and they just want to know how many of each letter is in the string. And it could be an infinitely long string, and this is not the optimal solution because I'm kind of live talking this. I just came up with that problem right now. And so the way you might solve it on a first thought is, okay, I'll just build an array, and that for each index in that array, it'll represent a letter. And I've confirmed with the interviewer that the character set is only uppercase A to lowercase z. And so I know then that I need 26 times 2, 52, an array of length 52. And so all then I need to do is iterate through the string and count each character, and if I find that character, increment it in the array. And so I would solve that by taking that and writing a simple example, writing our A, B, C, 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 D, or something like that, just a simple example, and then working my way through it verbally. I would say, so I would check this A, and I would say, okay, I would need to add to the element in the array that signifies our lowercase a, and so on and so forth. And so once you've talked through this base example, I haven't even started, I haven't written a line of code, I haven't defined a data structure. All I have done is work through a simple example case. And that helps you because if you jump straight into the code, you're more likely to make mistakes. This lets you formulate an entire plan before you actually get there. And so once you've worked through that simple case, you can start designing an algorithm. And I want to double check what my next slide is. Okay. So to design the algorithm, I kind of jumped ahead a little bit there. You're going to work out in your head how you want to solve it. Talk aloud. You don't ever want to sit there in a technical interview quietly for 3 minutes because the interviewer can't see what's going on inside of your head. So talk about it. Think about what you're about to say. Don't rush. Just take things slow and talk about it. So, okay, I see that there are an undefined number of characters in this string, and I need to count the characters in the string. Think about edge cases. What happens if there is a string with no characters in it? Clarify further questions because I can almost guarantee you if it's a problem of significant complexity, you did not handle all the ambiguous or unclear cases at the start. And then don't be afraid to correct yourself. If you make mistakes, say, oh, actually, I was wrong about this. This is how we want to do it, or so on and so forth. So a couple of algorithm strategies which really start becoming relevant when you start seeing problems of more difficulty than this. Exemplify, like we did here. That's the really easy way to do it. Look for patterns in it, not really relevant for this question. Simplify and base case, where you have this large complex problem, but really it's a bunch of little problems put together, and so you can use those little problems to build up to a bigger solution. And then just thinking about it in terms of data structures. For those of you who have had your data structures course, does a hash table make sense here? Does a stack or a queue or something like that? Because sometimes those data structures are an integral part of the solution and a good way to lead yourself towards the answer. So I jumped a little bit ahead and I kind of walked through those two steps as I was doing that. The next step is going to be to write pseudocode or just a spoken word example of your algorithm. And you can clarify with your interviewer, say, hey, I'm going to write code in a second, but first let's just write down and make sure we all agree on what's happening. And so you could write, for every character, create our array, for every character, check what it is, and then increment the item in the array by 1 that corresponds to that character. And so by doing this, when you actually start coding, you already have a written plan of what you're going to do. You can check that written plan before you even start coding, and then you don't have to worry about thinking about edge cases and things like that while you code because they are already in your written thing, and all you're doing is transferring those spoken words into code. So you're not trying to do two things at once. You're not trying to implement your algorithm and actually code your algorithm at the same time. All you are doing is coding the algorithm you've already written up. If it's an easy problem, like this one might be to you, it's okay to skip directly to coding, but it's never a bad idea, even if it's just a couple of short notes, to write out what you need to do. It makes a great checklist once you're done to go back and look at things. So now we're to the part where you actually write your code, and there's a couple of things to talk about. If you're on a whiteboard, make sure you give yourself tons of space. Don't cram a bunch of lines together right next to each other because you never know. You might have to go add stuff in, and it shows forethought. Those little things that they're looking for. Forethought and the fact that, oh, I might miss something at any given point, and so I should allow myself just enough space that I could add something in if I needed to. Don't worry about perfect syntax. If you're asked to code in Java, you should know the basics of Java, but you're not going to be expected to know the exactitudes of the string substring class, not substring class, if substring is from the starting point to the ending point, or if it is from the starting point and then the length. Those little things you can clarify with your interviewer and say, hey, I'm going to assume that this method is implemented like this is what it does, and they're not going to care if your arguments are swapped or you've got a minor syntax error. If you're allowed, use the standard data structures. Don't worry about implementing your own. Most of the time that's okay unless it's an integral part of the solution. And then ask about assumptions as they continue to come up. I know when I've done technical interviews, the last one I did, I was writing my actual code. I'd gotten that far, and I kept realizing, oh, I made this major assumption. I need to revisit. Is that okay? And what I kept getting told was, well, it's okay if you rationalize it. And I said, okay, well then I'm going to rationalize this decision, and this is my reason why. I'm going to document it right at the top. And so I think that helped me there. And then give yourself space for later revisions, like I mentioned. So once you're done writing your algorithm, we've got our algorithm all written out. If you're far enough along in your career that you know about time and space complexity, it's a good idea to say, okay, so for an input, this is bounded by this, and our space is bounded by this, your big O notation and things like that. If you're not far enough in your career that you've learned about big O notation, maybe take a look at it, but I wouldn't worry about it too much unless you are applying at one of those big companies. And then double check your assumptions and look at ways that it could be better. At this point, you've probably spent 30 or 45 minutes writing your solution. So if you come up with a way it could be faster, they're not going to ask you to implement it. But it's always good to say, oh, there could be a potential improvement here. I know when I did one, I manually converted between uppercase and lowercase when I could have just done a 2 lowercase. And so instead of having me implement that, he just had me mark with comments. And I said, okay, I would use 2 lowercase here. And it's the exact same as if it's what I'd done the first time, but it lets them see that after I'm done writing it, I'm still thinking about ways to make it better. So then the final part is testing your code. It's a good idea if you still have time to say, okay, for these couple of inputs, I'm going to run through it. I'm going to talk aloud and trace what happens through my algorithm, through my function, through my code, and see what happens. Think again about when it could be slow or edge cases it could fail on. If we had no letters in the string, could that cause it to fail? Or if we had a character that was not in our allowed character set, would that cause it to fail? Something like that. If you find something wrong, that's okay. You haven't failed. It's good that you found it. It's good that it shows that you had the forethought to test your code and that you're following through and you're making sure things are right. And again, they might not even ask you to fix it, but you can talk about how it is and make sure you think through how you're going to fix it. Don't just make a quick change and try and run through it again like you might when you're writing code. I know that when I have a null pointer exception, I might just change something minor and then run it again. But in an interview setting, you should really think about what causes the problem and then how to solve that. They want to you want to show that you're thorough and you're not going to rush through things. So, like I mentioned a little bit earlier, technical interviewing here at UC is a little bit different because we do the co-op program, right? A lot of interviewers here at UC aren't going to ask you a lot of the co-op employers here at UC aren't going to ask you the hard technical questions that you might see in Cracking the Coding interview, a book I'm going to talk about in a second, or elsewhere. There certainly are places that ask that for internships, your big companies, like I keep mentioning, Google, Facebook, Microsoft, things like that. But your local Cincinnati employers don't, not to say they never do, it's not as common as it is with the big ones. In my personal experience, I've been asked more about projects I've worked on, about experiences in the classroom, about experiences with leadership, than I have about actual technical whiteboarding code. I know I've been shown code and say, talk about what this does or what does this keyword mean, but for my local interviews, I haven't been asked much more difficult than that. Not to say you wouldn't be, but in my personal experience. And then brain teasers are also likely. I've been asked a couple of brain teasers. One of my favorite ones is on this sheet. Those are cool. And the rock in a boat in a pool problem is a cool one that I don't know the answer to. A couple of resources if you want to take this farther, and you certainly should. If you are prepping for your next big interview at a major company, do the legwork, do your mock interviews, and read the prep Look at cracking the coding interview. That is kind of like the holy grail of interview prep in the computer science software engineering world. You can find older versions online for free, I believe. There's Google, just Googling examples of questions you found. Google itself publishes a lot of guides on getting a job at Google and getting through the technical interview. HackerRank and LeetCode are two examples of online problem-solving websites. My personal favorite there is LeetCode. But again, that's a good practice into solving these types of problems, but you won't be doing it on a computer with a live compiler likely when you do the actual interview. But still, it's good practice. It's certainly what I've done a lot of recently. And that is all I have. So, any questions for me or anybody else who's done a technical interview if I can't answer? Cool. So you're more than welcome to come talk to me after we break into groups. For those that are interested in doing so, you don't have to if you don't want to. Come ask me questions or ask other ACM exec questions about what we've talked about today or about general involvement or anything really. Otherwise, I have a couple of sets of questions if people are interested in doing these in small groups. I've got easy questions, which easy, medium, and hard were probably not the way to word it. It is more based around where you are and what your knowledge level is. If you're a freshman or a sophomore, you've not taken the courses to probably know the data structures to solve the hard ones. So that's more what I meant. The easy questions are entirely brain teasers. I've got questions and answers. The medium questions are a little bit harder. They deal with strings. One is a linked list and one is arrays. And then I've got harder ones with binary trees, linked lists, and another one around parentheses with strings. So if you're interested in doing that, what I would recommend doing is come get one of these, get in a small group, and then talk through the solutions. Don't look at the answers until you've all had a chance to talk about it. If you would like to come up, I would be more than happy to be the interviewer and ask you some of the questions from any of them if you're interested. So, yeah, come on up if you are interested in doing that and grabbing one. And if you're an exec, if you would do the same thing I just offered to do for people that are interested. So, is anyone interested?